Hello, everybody. Welcome to Science Abounds Science at Home, where we will discover home lab magic. We will be doing experiments demonstrating scientific principles, concepts, and reactions in chemistry, biology, microbiology, microscopy, and even forensic science. Welcome to my channel. Hello, everybody. Welcome to another episode of Science Abounds Home Lab Science. In today's video, we're going to be demonstrating an example of an ion exchange reaction. The ion exchange reaction between sodium silicate, also known as liquid glass, and metal salts, and involves the exchange of cations from the salt with sodium ions in the sodium silicate, resulting in the formation of metal silicates and the release of sodium ions in solution. So today's reaction is going to take place in a petri dish, and we're going to be using 4 different metal salts to demonstrate this reaction. We're going to be using copper sulfate, iron chloride, manganese sulfate, and iron sulfate. So let's start the experiment and then we'll come back for an explanation. So I need about 14 mLs of sodium silicate. So I'm going to add about 14 mLs into the petri dish. And then I'm going to take each of my salts and add them to the petri dish, and let's see what happens. So first I'm going to add manganese sulfate, and I'm just going to add dropwise. Okay, and then next I'm going to add iron chloride. Next I'm going to add copper sulfate. Like so, and finally I'm going to add iron sulfate. Oops. And we can already see the silicate formation occurring. Okay, so what I'm going to do is I'm going to let that dry for a couple of weeks and come back to see what the formation of the silicates look like when they're dried. If we take, so what's going on? What is the story behind the reaction? If we take the generic metal salt, like a metal chloride, MX, the reaction can be represented by the following formula. An example is calcium chloride. Here, calcium silicate is formed and precipitates out as a solid. And why does this happen? The metal cations have a stronger electrostatic attraction to the silicate anion compared to the sodium cation. So they displace the sodium ions and form a more stable metal silicate. And this precipitates out as a solid. And as you could see from the reaction, they resemble jellyfish. That's the best way to describe how they look like. And the sodium ions, they then combine with the chloride to form the salt, from the salt to form sodium chloride solution. So this whole reaction, sodium silicate, has many types of applications. For example, water softening. Sodium silicate is often used in the water softening process. Metal ions like calcium and magnesium in hard water can form insoluble silicates and precipitate out, and thereby leaving and softening the water. Also, the glass and cement industry have uses of sodium silicate by the formation of metal silicates. During the production of certain types of glass and cement is a very important process. And here again, the sodium silicate interacts with the metal salts to form silicate compounds, which are important and used in glass and cement processing. Sodium silicate or liquid glass itself is an alkaline in nature. It is water soluble. It is resistant to high temperatures and acts as a binder, adhesive, and sealant. So sodium silicate itself has many uses in industry. And you can find more by checking out my video notes that I publish on my Patreon page. Well, I hope you enjoyed today's experiment, and please hit the subscribe button. It helps support my video. My channel keeps me making more and more videos. Also, please check out my Patreon page where I have exclusive videos of experiments that will not be shown on YouTube. I also publish all the recipes and background notes to all my experiments on Patreon and YouTube, and these can be found in my Patreon page exclusively for Patreon members. Please also feel free to leave a comment. Check out my link description because it contains all the information, all the resources that I use for developing and building and doing all my experiments. I list all my resources that you can look at should you want to do these experiments yourself at home. Also, feel free to email me your questions, your comments. Also, send me your photos and videos of you doing home lab experiments. I love to explore. I love to share and I want to develop a home lab science hobby community. So please feel free to email me. So until next time, keep on experimenting. Goodbye, everybody.